Okay, hello and welcome to the next video where we'll be looking into how to use Python in RStudio. So this does not cover the installation of Python. If you haven't done that yet, please go to the previous video and check out the description for for the link to a guide on installing Python. If you want to check whether Python was installed correctly, you can go up here and look into the terminal and then just type Python, which should launch a Python version, or in this case, for example, I don't have Python actually installed. So if I don't correct this is just some autocomplete that I have installed in my terminal. But I do have Python 3. So this might depend on how you have it installed. Just try both. And if one of these launches into this console, then you're good to go. And then you can exit this with exit. This is if you have to install a package. This is the place you would do this. So for example, for the later section of where we'll be using Python for data science, that's the coming video. But to install the packages for that, you will go in here and then either have Python or Python 3, depending on which one you have installed, -pip. So this is the Python package installer. Install to tell it to install something, because for example, you can also uninstall things. And then the package name. So this could be pandas, for example. And then you run this with pressing enter. This is a bit, I cannot demonstrate this here because I have slightly different Python installation where I actually manage packages differently, so it doesn't work for me. But for you, this should work just fine. So switching back to the console here. And let's first create a Python file before we can do anything else, because of course we need to run our files in something. And these Python files are kind of the equivalent to an .r file. So this is just a script. It's not like a nice R Markdown document or anything, which we'll be using for the next video. It's just one script file that's running top to bottom, basically, without any text in between. So for that, click up here. We have the default R script, but this is not what we want. We want to go a bit down, and then we do have here Python script. So this is already our Python script in which you can write commands. And again, in this video, we'll be covering the basics. So let's start with the most basic of functions, which is the print function. And similar to R, we can also just start printing values here in Python. So for example, that can be hello. And also similar again to running R files, we can just run Command Enter to execute our code. And you see maybe that already a few things have happened here. So if we look over here, you can see that quickly RStudio automatically launched this REPL. So again, we're actually running this Python code via R, which is just because RStudio is really first and foremost running via R, the way it chooses to do this. But still, it runs perfectly fine. And it's actually really nice because R automatically detects that you're trying to run Python code here, and it will then switch to using Python. The only thing is that sometimes this uses to, it tries to auto detect which Python version to use, and that can sometimes be a bit off. But if you only have one version installed, it should usually work just fine. And we can see here the output from the code I just ran, so it says hello. Next up, for example, we can already look into one of the first differences between Python and R. So Python likes to do things really simply, which, for example, you remember maybe how we can combine strings in R using the paste function, which might sometimes be actually a bit annoying, right? Like it's quite a lot of things to write for combining strings. And this, for example, is done much nicer in Python. So let me click one button here, as my screen would have turned off. So for example, what we can do in Python, if we want to combine two strings, is that or two characters, we just put a plus in between to combine these two. So for example, we have this, hello. Oh, and then we maybe want to have a space in between. And this. Of course, we could have also combined these together. This is kind of trivial, but then this way, it's gonna add all of these together into one big string. And again, here you can already see like it's a much simpler syntax. It might also be a bit weird, right? Because we're kind of using this plus for addition. So we're adding pieces of text, and then what it does is just combines them. Whereas R will just tell you, hey, text cannot be added. which might also be safe in a way. I mean, this really depends, right? But I actually found this quite a convenient syntax, to be honest. Next up, also in Python, we have variables. If we want to set a variable, so for example, here, we can add a new name that we want to greet. Again, I can execute this. You see, okay, I just created a variable students, and even actually R supports seeing the variables we have in Python here. You might see below here that we do have this list of name and students here, which is actually really quite neat, I feel. And then we can use this, or some here, replace the world with name. If we run our code now, it's gonna say hello students. What's important here, and where there's a difference between R and Python, is that while in R you can use both the equals sign and the tiny arrow, in Python you can only use the equals sign. So if I try to do this, which is a very R thing to do, it's gonna give me an error message, as you may see. So Python always uses this equals sign. Oh, no, I don't want to actually save it. Sorry, this is just my muscle memory of always saving files. Okay, so next up, also Python does have a few different data types that we can look into. So we already looked at characters here in combination with our print function. Besides this, we have numbers. So for example, 5 plus 100, we just use like this. We can also save them in variables, or the results in variables. Result is this, result plus 10, and we got 115. Else, the other two actually quite interesting ones are on the one hand lists. So if we have our list, so this is similar to vectors in R, but slightly different. For example, we can't just calculate with lists like we can do with vectors in R. So it's only really like a very rough mapping. Yeah, probably closest recommends to actual lists in Python, which are also a bit of an uncommon structure because you actually don't really use them that often in R. But basically in a list, you can just throw in whatever, and then you can access these things again via a numeric index. And that is the next big difference between R and Python. And that is, in Python, everything is 0 based. So the first item in this list is going to be at the position 0, not 1. In R, everything is typically 1 based. And it's so far, I think, the only programming language I know that does this. Almost every other programming language, including Python, uses the 0. So while it might seem a bit unintuitive now, this is actually a bit of more of the standard approach. So if I run this code now, you see we get the A, not the B. Not the B, but like it works this way, right? Like if you use the 1, we actually get the B instead of the A. So that's more, I think, what you might be expecting coming from R. So just good to know the difference between these two here. Yeah. And then last, we have one more data type, and that is the dictionary. Again, in R, this is typically done by named lists or named vectors. And you can already see that R is a bit more flexible in things, but also a bit less clear. And Python really just has like a much clearer distinction between these. And to create the dictionary, we use the curly braces. So you might already see like in Python, like a lot is being done via using different brackets. So we have these lists with the square brackets and the curly braces for dictionaries. So let's create our new dictionary. And what dictionaries have, it's always that they have a key and a value. So like a name for a value and then the actual value. And this is especially important because this is often used for initializing data frames in pandas. So our name is here, our name, and then the value might be our value. Sorry, I'm not the most creative today. Oops. And I wasn't clear here. What? Now it's being a bit confused. Okay, it seems to be a bit unhappy with us having this on multiple lines. Oh, wait, no. My bad, actually. I was missing a closing bracket. Let's see whether now it's a bit confused, but this should actually work. Yeah, okay. So it just turns out here that our suite is not as smart at running everything at once. So if you want to run multiple lines of code at once, we have to mark all of them. And of course, we always have to pay attention. So before I was missing this last quotation mark. And then with these dictionaries, we can also just get single values. Again, using these square brackets to get something from a dictionary. So now curly braces just for creating. Whenever we want to get something from an object, we use the square brackets in Python. And then we just give the name here. So our name. Whether we use single or double quotation marks, it doesn't matter. They just have to match. So don't get confused by that. These are just used to denote something being a character. Okay. Again, what's often being used in pandas is to create a data frame, is to have a dictionary with the curly braces. Then this would be the column name. And then in here, we would have the array with the values. And the last thing I want to cover in this basics video is how to create functions. And then we already have actually, I think, most of the basics in here. And it also shows one important concept in Python. And that is that indentation matters. So we create a new function using the def keyword, not the function keyword. That is the one thing I found a bit weird about Python, but it's the way things are. And we call this print to words. Not the most creative, I have to admit. First word, second word. And in here, we just call the print function, and we pass it the first word and the second word. Yeah. Of course, you could think of much more interesting functions, but I mean, this is just about showing the example. And with this function, we should try it out, of course. So let's do this and just call this via hello. We're gonna do it there. And what we can add maybe to our function is, so that it's not super boring, is that it automatically adds the space in here and exclamation mark at the end. So it's not at least super useless. So then we run this function code, and then we run our function, and it does what it's supposed to do. It has a surprising amount of space in here. That's weird. Oh, I wonder where that is coming from. Might just be the way, sorry, okay, yeah, this makes sense because we're actually calling this as separate things, but we want to add these to one. So it puts tabs in between if you just call it as different arguments, but I want to combine this to one character. And now it should print the way we want it to. Yes, now it just adds a single space in between. But what's important here, and you might have seen compared to R, where we have these curly braces for functions, we actually don't have these here in Python. So in Python, we only have this colon at the end to denote that's kind of the end of this function call. We have our brackets for the parameters, so this is similar to R. This is the name, so we don't assign this similar to R, like we just have def, our function name, and then the parameters. And then anything in the function is indentated. So it has some spacing here. And then Python knows that I'm done with the function, because here I'm back to the very left. And if I would have something in the function, I might have be like the cursor even further indentated here, right? Like if I have something nested in the function, I could even create a function in the function. It would be then indentated here. Or this would actually be here, but then my code would be on this level. Although it doesn't happen like that much. At least not with the kind of scripts you're writing here. Yeah, I hope this wasn't too confusing. Again, it's the exact same principles are, just sometimes the syntax being slightly different. And you'll also see this with actually all other programming languages. And in the next video, we'll be looking a bit more at doing data science in Python. Looking forward to see you there.